Okay, so for this alternate day 12 assignment, what we're doing on the first first 8 questions, all we're doing is we're looking for basically this f of x, what we are taking the derivative of. Make sure that you remember that this is minus f of x, so your signs are going to change. So really all we're doing is we're looking at whatever's coming after the minus, and that's our answer. That's what we're taking the derivative of. So in this case, we're subtracting tangent of x. So our answer is just we're taking the derivative of tangent of x. So this formula is just helping us find the derivative of tangent of x. In this case, we're finding the derivative of x to the fourth. Be careful with one like this. You're going to switch both signs, right? Because it's kind of like minus 2x squared plus 3x, right? You're just going to switch all of your signs. So we're taking the derivative of 2x squared plus 3x. Okay, and you'll just kind of finish the rest of these. Okay, for number 9, it says solve the equation. So we're actually going to kind of expand this out. So the limit as h approaches 0, we're going to FOIL out. So we get x squared plus 2xh plus h squared, if we FOIL that out, minus x squared all over h. Those are going to cancel out. We get the limit as h approaches 0 of 2xh plus h squared all over h. We can cancel out an h everywhere we see it since it's in every term. Alternatively, you could have written that as the limit as h approaches 0 of h parentheses 2x plus h divided by h, like factor out the h on the top. That works also. Either way that you do it, you should then end up with the limit as h approaches 0 of 2x plus h. Okay. From there, we're going to take the h going to 0, plug that in, and that gives us an answer of 2x plus 0, or just 2x. So our limit is 2x. It says discuss what this result represents. So what that tells us is that the derivative of f of x, or y equals x squared, is f prime of x equals 2x. Right, the 2x was our derivative. Okay, it says using the word slope and tangent. So what that kind of means is that the slope of the tangent line of y equals x squared is 2x. All right, on the back side, it says use the definition of the derivative formula. So this is the whole limit as h approaches 0 of f of x plus h minus f of x all over h. So what I like to kind of do is on the side, just write f of x plus h, which in this case would be 2 times x plus h plus 2. Sometimes I'll just go ahead and distribute this here. It makes it a little easier. So 2x plus 2h plus 2. Okay, f of x, you don't have to rewrite this one, but it's always just going to be the same as the beginning. So this is going to give us the limit as h approaches 0. The f of x plus h part will be the 2x plus 2h plus 2 part. And then minus the f of x part will be just our original. So in this case, that's 2x plus 2. Make sure you go ahead and distribute that all over h. That's going to give us the limit as h approaches 0, 2x plus 2h plus 2 minus 2x minus 2 all over h. Positive 2x minus 2x, positive 2 minus 2 all cancel. That's going to give us the limit as h approaches 0 of 2h over h. We can cancel out the h's, and we're just left with 2. There's nothing to even plug in. It's just the number 2. 11 will be very similar. On 12 and 13, it's similar. You just have to FOIL it out. I'll do 13 as an example because it's a little trickier. So f of x plus h will be x plus h squared plus 2 times x plus h minus 1. If we FOIL this out, we get x squared plus 2xh plus h squared. Here we're going to distribute plus 2x plus 2h minus 1. I'm not going to rewrite f of x. It's already written. So then we have the limit as h approaches 0 of all of this. So x squared plus 2xh plus h squared plus 2x plus 2h minus 1. I'm going to put that all in parentheses, minus x squared plus 2x minus 1. If you want to get rid of the parentheses and just change each sign, you can do that. So, I'm going to kind of save a step here and just kind of distribute that parentheses. So it'll be minus x squared minus 2x plus 1. I've kind of already distributed that parentheses. Positive x squared, negative x squared cancels. Positive 2x, negative 2x cancels. Negative 1, positive 1 cancels. That gives us the limit as h approaches 0, 2xh plus h squared plus 2h all over h. Anywhere I see an h, I can cancel it out since it's in every single term, which is the limit as h approaches 0 of 2x plus h plus 2. Now we're going to take the h, plug that in, and that gives us 2x plus 0 plus 2, which is 2x plus 2. That's our answer. Okay. 14, very similar to 10. And then 12 and 15 with the x squareds are similar to 13. So you have some kind of examples to help you out. 16 and 17 are both optional. It's not extra credit. It's just if you want to try it, I would encourage you to try it. In both cases, you'll do, an f of x plus h. This will be radical x plus h plus 4. You can drop the parentheses, so you just have x plus h plus 4. And in this case, the f of x plus h will be 1 over x plus h plus 4. So in this case, you're going to need to multiply by the conjugate. And in this case, you're going to need to either multiply by the denominators or get like denominators and kind of work so that you can cancel out that h in the denominator. Right? If you notice in both of these examples, after I canceled out the h in the denominator, that's when I was able to get an answer. Here as well, after I canceled out the h in the denominator, that's where I was going to get an answer. Now in these cases, I just had to basically expand it or FOIL it out, right? But in these two challenge cases, we're going to need to conjugate or multiply by a denominator, kind of get like denominators to get everything to cancel out. Anyways, that should help you guys. I'm not going to post a full answer key because I think this is more than enough for you guys to get started and make sure that you're on the right track. But if you have any questions, let me know, and we'll go from there.